Hey guys, I saw what's the crack. I appreciate that. How are we doing? Excited for summer school? I saw a lot of you talking about your results day. Feeling good about results? It's like 2 weeks, right? You guys can hear me okay, yeah? Hopefully. Hey, happy days, thank you. Psych, philosophy, physics, math, and politics. Physics. Oh, so Elliot, are you going to do both the chemistry and physics summer school and then like decide which one you like better? Is that the kind of like the vibe you're going for? It's kind of smart if that's what you're choosing to do. Hey guys, thank you for saying hello. Hey Mina. So results are in 2 weeks, right? So we're just going to give it like another 2 minutes before we start. Just while we wait for a couple more people. You're in year 10. You're like getting well ahead of yourself, eh? I'm grand, thank you for asking, Aria. Happy it's summer and the weather's finally better, eh? You can get outside. I heard some of you talk, or not heard, I saw some of you there talking about having a dog. That's what I've been doing, just taking them out for walks all the time. Denny's gone any like, holidays or anything over the summer? Take your minds off your results? Your sister from Key Stage 3 is joining. If she can do year 12 physics, she's going to be flying, eh? What's the crack? Yes. And you spelled it right. Happy days. Good job. You're going into year 11. I would say today it's probably quite good because we're kind of doing like a review of GCSE stuff, like getting you ready for like some changes for year 12 physics. But yeah, you're kind of doing the right thing anyway if you're revising over summer already. I just think definitely don't do the thing that everyone does where they wait for the last few months to revise hardcore. You got to be revising from the start, right? Especially when those grade nines. You went to the Eros tour. I actually know what that is because one of the guys who work here was talking about it. That's your doll Taylor Swift, right? We made like a little like a reel on it, one of the Instagram reels. Was it good? The Eros tour, Taylor Swift, right? We did like a reel about uh the noise levels coming off the concert, and like the ground was shaking, so it felt like a mini earthquake. You're a Swiftie. Yeah, the CGB books are really good. We were actually talking about that, like a few of the teachers here. They're really good. Right, it's 11:01. So just a little bit about me then. So before we start, so hopefully I know some of you maybe from if you joined the cram courses or like the Easter revision courses just before your exams for your GCSEs. But if you don't know me, and hopefully you're new, so I'm Brooke, clearly. So I loved math in high school. So I did math, biology, chemistry, and physics. And kind of like someone was saying there, I think it was Elliot, I didn't know which science I liked better. I honestly liked all of them equally, and I was just good at them, right? So I just had a science brain. So I took all of them, and I loved it. And then when I was in my physics classes, I just loved my teacher. He was just good crack. He always took us on an experiment, like we did loads of experiments. We went on loads of school trips to see lectures, and I got really into astrophysics. So Evie, yes, astrophysics. So astrophysics, if you don't know, is like studying physics of space. So my dad was like super into Marvel movies and Star Trek and Star Wars, and I grew up with all that. So I guess I just got really into like I thought space was really interesting, especially like black holes and just seeing like supernovas. So then I just went down the physics line, and that's why I did astrophysics at Michigan State. Did anyone know? MSU maybe? So it's in America. And then I came back here to do my master's in astrobiology. astrobiology. That's what I wanted to do. Sorry, I did my master's in planetary science. So planetary science is like you look at things on our planet and you want to see like how they'd be similar in different planets. So for example, if you're looking for so like just decline, just like exoplanets, yeah. So it's like looking at conditions on Earth, like what the volcanoes look like, what the waves, what the water structures look like. So then we observe those structures on different planets, what we can deduce about what they used to be like, how they formed. So I was into that. And then astrobiology, I mentioned, was the next goal, like if I wanted to keep in school. I don't know if any of you heard of astrobiology. So it's quite cool, especially if some of you are thinking between like biology and physics. So astrobiology is like basically looking for life on other planets. And people thought that was mad a few years ago, right? Like, how is there life on other planets? But then now they think it's extremely likely there's even life in our own solar system. So yeah, then I got into teaching and now I'm here. So that's my crack. And just to see how you guys are then. So yes, I can. I apologize. It's the accent. I will slow down. Thank you for saying. Do you guys want to have a go at these ones then? Oh, Aishan, your teacher told you about MSU. That's cool. Yeah, did they mention about the cyclotrons? So it's one of the very few universities that have 2 cyclotrons in their campus. They're really good at nuclear physics as well. Is your teacher American or how do they know about it, Aishan? Yes, Amin, habitable zones for stars. Yeah, like the Earth is in the habitable zone. That's really good. Yes. Sorry if I pronounced it wrong. Seer. Brilliant. Thank you. So really nice that it's just straight on to the questions there. So it says, what is distance traveled by the athlete? So nice that we're thinking distance, he's saying, is a scalar, whereas displacement is a vector. So again, hopefully it's just like jogging your memory because it's probably been a while, right? It's been a while since your GCSEs. So just like jog your memory about the things that you did learn in GCSE are really important, that you understand them fully going into year 12 physics, right? So hopefully this summer school is just going to set you up quite nicely that when you do year 12 physics in your school next year, that you'll go in guns blazing, right? That you'll remember things from your GCSE. You won't have those 2 weeks of being in a fuzz. And no one likes that, right? When you go to class and you feel in a bit of a panic because you don't know what's happening. So hopefully summer school will just prepare you really well for what year 12 physics will be like as well. Yeah, nice, good job. So distance traveled by athlete, brilliant. So the distance traveled by athlete, just what we said there, is the 300 meters, the whole distance. And then Aishan, beautiful, the displacement, right? So displacement is your vector. So I think it was Seer there above said that distance is a scalar. So hopefully you learned that, you memorized that for your GCSEs. So remember, scalars, they only have a magnitude. Okay, and it's really important you know this as well for your A-level physics, right? So a magnitude just has a size, it's just a number. Whereas a vector, which is what your displacement is, it has to have a number, a magnitude, and a direction. So you'll give it a magnitude and a direction. So you got to give it both. So it's really nice then that H&M wrote above. That's why we're going to write that it's 75 meters north, right? And you can see here, I kind of put a hint to show you the scale, the directions, right? So north, east, south, and west. Yeah, nice, good job. So hopefully we can see there, and it's 75 meters north because displacement's basically asking you how far away did you end from where you started, right? So we can see from where they ended and where they started, there's 75 meters north. 75 meters north. Yeah, fab. Okay, what will be this one? What's their average speed? If you can pop it in the chat. Yeah, Aria, I'll change your mind. I'm telling you. I'm going to make you a fan of physics. Yeah, so this is your year 12 physics course. It's like an intro to A-level physics. Yes, nice. Fernandez, if I said that right, sorry, you're close to what I want, you just missed something. Yeah, so this is like the first kind of change from your GCSE to your A-level physics, how you write your units. So loads of you did a really good job of getting the magnitude right, the number right. So we look at it here, we want to know their speed. So nice that we all remember the equation. Speed is distance divided by time. I'm just going to pause there actually. So you guys were at a really good advantage for your GCSEs because you were given that big data sheet, right? You got given all the equations, but that's actually not great going into your year 12 physics because yes, you do get a big data sheet, right? You'll see it, it's like pages long, but you get 1 minute roughly to do each question in your year 12 exam, your year 13 exam. So you don't really have time to be strolling through the booklet all the time looking for the equations. So that's one thing I would recommend on your next month before you come back to school or next 3 weeks is that you do try to memorize a lot of those equations because physics will be very hard. And I will say that if you don't learn the equations, okay? So we'll go over maybe at the end a list of the ones that I think you should try and recap. But things like kinetic energy, things like power, they're just equations that you should memorize. So nice that we all said distance divided by time. So we just said earlier, the distance was 300 meters. We said her time was half a minute. It's really nice that everyone remembered it has to be in seconds. So half a minute is 30 seconds. So when you divide those together, which is really nice, everyone got 10. And then that's the big change, right? So in GCSE, you wrote 10 meters/second, meters per second. But now in physics, you won't get your marks if you write it like this, okay? So some people try to do it there. You have to write it in your indices. So Ishan, yeah, you're flying ahead. Ishan, perfect for the next one. Yeah, good job. And Justy Kang, yeah, brilliant, right? So just to remind you about math. So when you did math, if I have 1 over x, I can write that as x to the power of -1, right? All that means is 1 over x. Or for example, if I have 1 over x squared in my math classes, I learned I can write x to the -2, okay? So that's how we have to write your units in physics now. So instead of writing 10 meters per second, we're going to write 10 meters. Instead of it being over a second, we write 10 meters and then s to the -1, right? Because it's over the second. So it's the indices rule. So just make a quick note for yourself there that from now on, you have to write your units in your indice form. You can't write the slash. Okay. Yeah, so I mean, this is year 12 stuff. So everything we're going to do over year 12 summer school, the first lesson now is just to make sure you remember all the equations because you have to use these in year 12 physics. So everything we'll do today, you do need to know for year 12 physics. So when you do year 12 physics, the first lesson you always have at the start of a topic. So for example, one of the topics you'll have is waves. One of the first lessons you'll have is recapping everything you did for your GCSEs to make sure that you understand that fully so you can go into your A-levels and learn the more detailed stuff about the waves. Yeah. Okay, so I saw one person gave a go there at writing this in kilometers per hour. So can everyone else have a go at that? So if I've got 10 meters per second, how do we put that into kilometers per hour? So how many kilometers is that in 1 hour? Ishan, you're very fortunate they did that. Probably not the best use of your time for your GCSEs though, but it's great for your going into year 12 and year 13 physics. Yeah, Evie, beautiful, good job. And then Evie, I know it's really hard to type on your keyboard, but if you kind of just type it on your keyboard, it's like if you hit Shift 6 on your keyboard, Shift 6 will give you that little up arrow. So it's like telling me you want to give me to the power of -1. So just try to practice that so we can get into the way of units because that's one of the biggest changes. It's really hard to get out of the way of changing it. Okay, so just make sure we're good. I'll show you how I would do it. So 10 meters per second means that this little girl, she can run 10 meters in 1 second. Right? That's what it's telling us. So if I want to know how many meters can she run in 1 hour, that's what we're trying to figure out. It's kilometers per hour. So if she can run 10 meters in 1 second, if she's going for a whole hour, she can clearly go further, right? So to get from seconds to hours, I multiplied it by 60 to put it into minutes, and I multiplied by 60 again to get from minutes into hours. So your calculator, if you do 10 times 60 times 60, you get 36000 meters. So what I figured out is how many meters that girl go in 1 hour. But the question wants me to figure out how many kilometers can she go in 1 hour. So to get 36,000 into kilometers, I remember from my GCSEs, 1k of cash is like 1,000 pounds, right? So if I have 36,000 pounds, I want to figure out how many k that is, you just divide by the 1,000. So that's how we know it's going to be 36 kilometers in 1 hour. So because it's 36 kilometers per 1 hour, that's why we can write 36 kilometers per hour. Okay, so that's your final answer there, 36 kilometers per hour. So this type of question sometimes comes up in the multiple choice. So year 12 physics is actually quite nice because your first 4 or 5 questions, the written questions are quite long, quite a lot of math, but then the last like 20 questions are all multiple choice. So the multiple choice, obviously you always answer it because you've got 25% chance of getting it right? But there'll be questions like this, making sure that you're okay just doing the basic math. Oh, Anina, that's a really good question. So there's loads of calculators out there, right? And there's loads of new ones out there as well. All the calculators are different. The one that you're used to, as long as it's scientific, just keep it because you're going to be an expert at your calculator, right? So for example, there's 2 here in the room right now. So there's this calculator that I have never used and I don't like it. Okay, but if you're someone who's used this one all the time, it's good. Whereas mine's still Casio, still really simpler. But I got this when I was your guys' age, like 16. And I've literally kept it since I was 16. I love this one. So it's just to make sure you need to know how to write it in because my calculator, it does order of math the way I type it in. But some of the newer calculators does order of math in BIDMAS or BODMAS, wherever you called it in school. So you just have to be very careful that you know how your calculator does the math functions. Yeah. Okay, next one. So this one says, explain why the runner has a maximum speed. Okay, this type of question came up quite a lot in your GCSEs, right? Asking you about how a runner gets maximum speed, how a car gets a maximum speed, how maybe a swimmer reaches a maximum speed. Does anyone, can you type in that chat what would be your answer? Or type it in your booklet, which is really good. But nice if you keep your booklet for the answer so you can like review it before you go back into school, which would be quite good. But what do you think? Why does a runner get a maximum speed? Why does a runner get a maximum speed? Nice about terminal velocity, good job. Terminal velocity is more when you want to talk about things like falling through the air. So like you might have probably talked about terminal velocity in school when you said about someone who jumped out of an airplane. So we'd say they reach terminal velocity because it's kind of very similar lingo, but terminal velocity is more when you talk about things falling out of the air or talking about things falling through water. This one is more someone running through the air. Yeah, Jeffrey, thank you. Yeah, terminal velocity only applies when free fall. Yeah, brilliant, Jeffrey. Summarize it nicely. Metabolic rate is really good, you know that, but yeah, that's more if you're trying to do biology. We do talk about that. So I'm kind of just asking you, why do they reach maximum speed? So let's think about the first thing when they're running. What do you know about them? What 2 facts you know about when they just start running? What's really high? What's really low? Air resistance is what yeah, thank you, Erin, good job. Air resistance is what we're talking about. Yes, Catalina, is that how you say it? Catalina? That's beautiful. The runner accelerates, then slows down, not tiredness. So you could combine your answer with Aaron's answer. That'd be perfect. Yeah, air resistance, beautiful. Yeah, so it's kind of the start what Catalina said. So the start, we want to say that there's going to be a really high acceleration. Okay, so the start, there's a really high acceleration because the forward force on them is much, much bigger. And then what do we know about air resistance as they start to get faster and faster? What happens to it? So again, they've just started running. They're getting faster and faster. They've got really high acceleration. But as they're getting faster and faster, yeah, thank you, Isham, beautiful. As they're getting faster and faster, this force of air resistance increases, right? And we all know about that, right? Because you think about if I go for a walk, my hair will barely move. But if I go for my runs, my hair will start flying back with the wind. And if I'm in a car, right, and it's going really fast, and I'm going to stick my hand at the window, which you probably all did as a kids, right? Your hand gets like flung straight back because the force of air resistance is so high. So we know as this person's getting faster, as their speed increases, so they're running, as the forward force is the same because their legs going to give them a certain output, but their air resistance is getting bigger and bigger and bigger until they become equal. And then when we become equal, we know that person is traveling at what? So they'll stop accelerating and they'll start traveling at what? Yes, reach your maximum speed because the forces are now balanced, they're equal. So not terminal velocity, because remember, terminal velocity we only talk about when we said about free fall. So terminal velocity is only like, I think someone mentioned it earlier, say something falls out of a tree, like an apple falls out of a tree, or if someone jumped out of an airplane and was falling down. Yeah, constant speed. Thank you, Karis. Good job. So once those forces are equal, they then start traveling at a constant speed. Right? So maybe if any of you watch the Olympics right now, you probably see the athletes when they take off the start, right? They're going super fast, but then they don't keep that the whole time because the air resistance increases, and eventually they've reached the maximum speed that athlete can get to, and that's why they keep running at that same maximum speed. And there's loads of things you think about athletes, or can anyone pop in the chat? For example, if I was in the Olympics right now in the 100-meter track or in the 300-meter track, what type of clothes they wear, how do they present themselves, how do they actually make sure that they can go as fast as possible? So think about athletes. What do we want to do to make sure? Yeah, streamlining. Yeah, brilliant, right? So you probably see athletes all the time, like running athletes, right? They're not wearing, yeah, thank you, lifts clothing them in. That's exactly what I was talking about, right? The athletes are not wearing really baggy clothes, and all the girls running don't have their hair all down, do they? Because that's too much air particles having contact with you, right? Because your surface area would be really large. So what they do is they always have their hair slicked back. They always have super tight lycra clothing on. Same with swimmers. They want to wear the swimming caps to make sure there's no water resistance with them. So again, we can get as fast as possible as long as it takes the longest time for this air resistance to get equal to the forward force. Okay. Yeah. Okay, brilliant. And I think I saw someone say they want to do number 5 again. Yeah, that's grand because it's really useful. So again, what we said here is we've got 10 meters per second. Just going to rip this out so I can do it again. So if someone goes 10 meters in 1 second, what we're saying, I want to know how many, they go 10 meters in 1 second. I want to know how many kilometers can they go in 1 hour. That's what we're trying to do. We're trying to put it into kilometers per hour. So if they can run 10 meters, she's a wee girl, she can run 10 meters in 1 second. I want to know how far can she run if she had a whole hour, right? So clearly if she had a whole hour, she can go much further. So that's how I know I have to multiply. So I multiply by 60 to put it into minutes, and I multiply by 60 again to put it into hours. So what I do here, if I multiply this side by 60 twice to put from seconds into hours, I have to multiply this side by 60 twice. So I do 10 times 60 times 60 in my calculator. I get 36,000 meters. So 36,000 meters is how far she can go in 1 hour. But I don't want to know how many meters she can go 1 hour. I want to know how many kilometers she can go 1 hour. So to go from meters into kilometers, I just divide by 1,000. So I divide by 1,000 to get a final answer of 36 kilometers in 1 hour. Yeah. Yes. Yeah. Sorry if I say it wrong. Alia, if you can do the other way first. You can do kilometers first and then seconds. Whatever way you like better. I like imagining that if someone's going for a longer time, they could clearly run further. Aria, I'm so happy to hear you're liking physics now. Yeah, Chloe, beautiful. They're wearing lycra. Yeah, nice. Okay, so hopefully you guys are doing summer school because you're going to do year 12 physics course next year, right? So you all know that there's going to be a year 12 physics course that I'll be running through the year alongside you being in school. So it'd be nice then if it's the same people, I get to know you a bit better. So I guess I'm just a bit curious about if you guys tell me so I can at least talk about it with you a bit more through this lessons. Why are you actually choosing physics? Like what is it that you like? Do you like it because you're just good at it? Do you like it because you think it's interesting? Someone mentioned before they liked it because they like astrophysics. So is there a reason that you got into astrophysics? No, so the course that I'm doing over the year alongside your school courses, it's not free, but it's much cheaper than a tutor. So I used to be a tutor when I used to be a teacher. Well, today I'm a teacher, but when I've been working in a high school, and it's mad expensive for a tutor for your A-level physics. So this is just a really nice way to like make sure that everyone can be accessible towards physics. Physics is beautiful. Yes, here. Go on, elaborate on that. What do you mean? What is it that you think is beautiful about it? Natural sciences Are you thinking about Bath University then? Just decline. I think Bath's got a really good natural science program, don't they? Yeah, that's true. And I actually think, sorry if I say it wrong, SAS. I actually think you'll enjoy physics probably more than math and further math, because math and further math is just applied math all the time, right? But then physics, you're applying it to like problems in your actual life. Ah, that's a nice way to say it. Yeah, it gives math a meaning. Yes, Ishan, computer science, that's where the money's at in the future, I'll tell you that. Especially if you're good at coding. Engineering, what part of engineering, Kendall, are you into? Oh, Queen's Mary. Yeah, there's quite a few people here. Area. Medicine as well. I'm sure you know, but doctor's a hard life, right? But there's quite a lot of medicine in physics. So, for example, radiology. So, people with cancer who need to go get radiation treatment. It's not a doctor who's allowed to do that. It has to be someone who understands physics. So you still work in a hospital and you still give treatment, but you work in the radiology department, trying to help people with cancer, treat cancer, cure cancer. The laws of the universe. That's cool. I think space. Architecture. Yeah, I just taught a student actually who was really into architecture. He's actually really into architecture of church arches. He did a whole presentation on it one time. Aerospace engineering. That's really cool. So are you like hoping Elon Musk is yes? Formula One, Kendall, awesome job. So actually Noah did. He went to university with us. So he got employed as Formula One. So what he does then, he gets flown around first class airplanes all around the world to go to different tracks. And what he does then is he looks at the conditions of the air that day. He looks at the humidity in the air. He's looking at how much water, how much surface water is on the ground. So then he can judge what type of tires you should put on the cars and things. So he loves that job. That's a really good job. The brain, that's a good one. Yeah, neuroscience. That's quite a lot of physics as well, which is good. Yeah, cool. Okay, it sounds like you guys are quite inspired about it. Yeah, so for me, I just loved it again because I just think it's one of the few subjects you do in school where you're actually learning the peak of our knowledge. So the stuff you do in biology, people have known it for years, right? But when you do year 12 and year 13 physics, you start to learn about wave-particle duality, how particles can be waves and waves can be particles. And that's the peak of our understanding right now. No one can properly explain why that happens. We can talk about the theory behind it, but people can only do it for hydrogen right now. We don't understand the math for anything heavier than hydrogen. So I just think it's fascinating that when you do physics, you're learning the peak of the knowledge. So when you go to university, the whole goal is to always expand on that knowledge. Okay, so what we're going to do then is we're going to spend the last half an hour then just doing some questions to just get you ready for the rest of the summer course, get you back into the math, right? Okay, so speed and velocity, we did this earlier and people already said it. I just wanted to make sure I highlight this is really important in year 12 physics because we're going to start projectiles. So projectile motion is like if you kick a football and you're trying to calculate what way that football is going to go. So if you look at it here, one way that you probably did it in GCSE physics was you can say this red car is going 50 meters per second. But again, remember, we don't do that anymore. It's 50 meters per second towards the right. So that's one way I can talk about my vectors. Or I can say this green car is going 50 meters per second towards the left. But you don't really write the words as much in physics. So what you'll do now, you should always give it positive or negative numbers. And the way that I'll always be teaching it, and some teachers are a bit different, but the way that I always teach it is anything that's always going towards your right is going to be positive numbers. And anything that's always going upwards is your positive numbers, right? So it just makes sense for me. Up is positive. So then anything going down will always be negative numbers. And that's just me writing negative fast, so negative. And then anything that's going towards the left will always be negative numbers. So the red car, I'm going to write plus 50 meters per second, right? So that's me telling the examiner that I'm giving it a vector because I've written plus. And the green car, I'm going to write negative 50 meters per second. Okay, so it's just much faster as well. And that's what you'll start to do for physics now, okay? So it's always going to be positive and negative. Okay, and the positive and negative just means if someone's going right or left, or if it's going up or down. Okay, yeah, Ishan, beautiful. Same as the graphs. Okay, so just really quickly, and to make sure we're good, can you pop in the chat what's this missing word, and then can you also make like 2 columns in your work pack. So one for scalar and one for vector, and then just sort these words into whether they're scalar or vectors. Yeah, beautiful. Vectors have magnitude and direction. Lovely. Thank you, Seer. Thank you, Aishan. Thank you, Evie. Carol. Lovely. Carl, I haven't seen you yet, so nice. Thank you. And Min, if it's something going up and towards the left, we give it like, not like bearings, but similar to bearings. So we're going to do about that in a few lessons. Good question. Direction, direction. Yes, lovely. Amina, lovely. Thank you for people not seeing your names before. Yes, lovely. Yes, Justy Klang, Pythagoras, beautiful. And then I just saw someone type in the chat there. So just while I'm talking about what was in the chat, can you see now if you can sort these words into if they're scalars or vectors? Okay. So you can maybe pop in the chat distance and then write an S beside it, or write a V beside it, or just pop in your work pack. Displacement, you pop in the chat and write an S for scalar or V for displacement. So I saw someone wrote in the chat about, do you need to do math if you want to do physics? So some schools require it. So the school that I've just taught at, we wouldn't let you do physics unless you did math also. Some schools don't require that. They let you do it. But I honestly really believe that when you do physics for 2 years, you'll love it, right? It's just, like I said, it's fascinating that you're learning the top of our knowledge. This stuff doesn't make sense, but it's beautiful because it doesn't make sense. So someone said earlier, it's beautiful. But there's no point doing something for 2 years if you can't go to uni for it. So if you look up at a university, maybe after this, so say you want to go to Bath to do physics, or you want to go to Durham to do physics. If you look up a physics degree, the entry requirements to get in, they'll not let you in with just physics alone. So for example, I can't remember off my head, but I think it might be Durham. To do a physics degree, you have to have, I think it was an A star A, B, or A, and you have to be physics with math. So if you only did physics and you got an A star, they'll not let you in because you didn't do math alongside it. So it's not smart to take physics without math in case you want a future in it. You've kind of shut that door already. Okay, so nice. I'm seeing momentum is a vector. I agree. So momentum is our vectors. I'm seeing displacement, cut E, nice, is a vector. I'm seeing distance is a scalar. I agree. I'm seeing velocity is a vector. I agree. I'm seeing force is a vector. Nice, because it has to have a direction. What else do we think? Rookit says time is a scalar. Nice. Rookit says temperature is a scalar. Nice. What are we missing? Volume. What are you thinking about volume? Time is a scalar. Thank you. Yes, I missed that one. Time is a scalar. Good job. Nice. I saw there a lot of people saying acceleration is a vector. I agree. So we've got distance, displacement, speeds. What are we missing? Volume. Volume is a scalar. Lovely. And thank you for that last one there. Thank you, Amin. Mass is also a scalar. Nice. So clearly we can see for anything on this side of my table, all that matters is giving our magnitudes all the time, just that number. But anything on this side of the table, we're now going to give positive numbers if they're going towards the right and negative numbers if they're going towards the left. Positive numbers if they're going up and negative numbers if they're going down. Yeah. Okay, for this one says we've got a force in a box. So it says 20 newtons. It says on your work pack, can you draw another force with a magnitude of 40 newtons acting downwards? And can you calculate the resultant force? So if you did triple physics, you probably learned how to do this quite well. If you did combined physics, you probably didn't, but you probably learned your math. Okay, so I've got 20 newtons going towards the right and I want 40 newtons going down. So 40 newtons is double 20. So I'm kind of drawing an arrow that's double the size and label it my 40 newtons. And I want to know what the resultant force is. So how do we find the resultant if I have 20 newtons going towards the right and I have 40 newtons going down? Do you remember from math? Someone said earlier about Pythagoras. So what's the resultant force? Yeah, I'm in. Beautiful. Very fast. Good job. So Min said it's going to be 44.72. Yep, or 721 newtons. Thank you for writing newtons. Lovely. Yeah, we do use Pythagoras. Good job. So hopefully we know Pythagoras. If I'm doing Pythagoras, I know a squared is equal to b squared plus c squared. And then how you learned that in math was, say I've got a right angle triangle. So there's my triangle, there's my right angle. The longer side, or the hypotenuse, the one that's directly opposite that angle, that's your A. And then the other side, doesn't matter which one you label them, A, B, and C, or the other way around. So A squared always equals the sum of B squared plus C squared. So if I want to find out what that resultant vector is there, all I need to do is do 20 squared plus 40 squared, and then I square root it. Yep, so perfect how Catalina wrote it. Yeah, lovely. Lovely, lovely. Nice, guys. Good job. So when you do this math in your calculator, you'll get a final answer of 44.72 newtons. 44.72 newtons. Okay, so 44.72 newtons. Direction, Xavier. Yeah, nice. So can you give a go? How would you write the direction? Does anyone know? It's more, you would have done this in your math classes, not in physics. How do we define direction right now? So let's say, okay, yeah, you could use a protractor or a ruler. So if I want to know this angle, does anyone know how we find what this angle is? So I'm going to say that vector is so many degrees below the horizontal. So let's say that's my horizontal there. So horizontal is like horizon. It's like if you look at your horizon, it's the flat plane. Yeah, we do use trig. Yeah, good job. Yeah, so to use trig, so I wasn't going to do this, but just because people asked about it, it's nice. You do have to do this for physics in year 12, so we are going to learn this together. But to do trig, everyone's got a rhyme for it. I think a lot of you learn right now Kotatoa. I learned, you're probably not like mine, but I learned top, cat, sat, on, an, orange, and howled horribly. So then I just make it into a little grid. So to find tan, I do opposite over adjacent. So, but people did Kotatoa probably know Kotatoa. Sokotoa area, thank you. You're right, it's Sokotoa, it's not Kotatoa. What am I talking about? Sokotoa, thank you. So to find this angle then, I know the opposite, I know the adjacent. So for me, I do my tan is opposite over adjacent. So tan of that angle is the opposite, which is 40, over the adjacent, which is 20. So to find the angle, you just hit shift tan in your calculator. So you take like the inverse of the tan. So you do shift tan your calculator and you just do 40 divided by 20. If my calculator will let me do it. 40 divided by 20. And I got 63.4, the exact same as Justy Klein. Yeah, good job. So how we write it here now is 63.4. So a final answer in physics now, which we're going to practice doing this. So we're going to do 44.72 newtons at 63.4 degrees below the horizontal. Okay. Yeah, so trig you're going to have to learn and use in physics. So we'll practice that a lot more. Yes, Sokotoa. Thank you, Sokotoa. Or learn mine. Top, cat, sat, on, an, orange, and howled horribly. Okay, so what about acceleration then? So you've probably seen this equation and it was given to you in your GCSEs. This is another one that I'd highly recommend you make an effort to learn, okay? So you just want to be, when you see these questions, physics, you want to be super quick at them. These are the easy marks that you just want to fly through them so you can spend as much time as you want on those harder questions, okay? So just to make sure we're good with units, I popped it here for you. So remember speed, instead of writing meters per second like you did in GCSEs, we write it as indices now, so meters per second. And acceleration, you've always learned, is meters per second squared. But remember, like we talked about earlier, 1 over x squared in math becomes x to the minus 2, 1 over x squared. So that's why I can write it ms to the minus 2 now. Okay. So the first one, it says, a man riding his bikes accelerates from rest. So that means they start at 0 at a rate of 0.08 meters per second squared. So what I'm going to do, I know acceleration is going to be the change in velocity, final minus initial over time. Okay, the way I learned it was, you know, if you sing the alphabet, A, B, C, D, F, G, it's U, V, W, X, Y, Z, right? U comes before V in the alphabet. So U is always the initial speed, the first one. And then V is always going to be your final speed because it's the second letter in the alphabet, okay? So that's why it's always going to be final speed minus initial speed over time. So to look at this now, I know that 0.08 is equal to the final speed that I'm trying to figure out. So final speed minus initial speed over time is 30 seconds. So we're just going to practice now some rearranging to make sure you're good. Yes, here, we are going to do that, but we're going to do that more when we do the year 12 course if you do it with me for the year. This year 12 course is kind of more just getting you ready for the first month of your year 12 physics. Okay, so if I do this now, what I've got is 0.08. Anything minus 0 is just the same number, v, over 30. And then if I want to do this math, hopefully everyone's okay with rearranging, we multiply both sides by 30. So I know a lot of you probably were shown equation triangles in GCSE, and I did teach equation triangles in GCSE because it's the quickest way to do math to get you a high grade, but you can't use equation triangles in your physics in year 12. So hopefully everyone can see if this is my equation, if I've got 30 in the bottom, I'm going to multiply both sides by 30 to get rid of it, right? Oh, why 30? 100%. Thank you, Amina, for paying attention. I can't do time, can I? It's over 60. Thank you, Amina. So it's over 60 because it's 1 minute. So we're going to multiply both sides by 60 to get rid of that 60 in the bottom. So I multiply both sides by 60, which I hopefully did a minute ago. You get 4.8. So my final speed is 4.8 meters per second. Okay, so 4.8 meters per second. Yep, CFK, beautiful. But just remember, unfortunately, you can't get your marks to that. So I know it's really annoying to write it in your type it in the chat, but just try to get the hang of it. So you have to hit shift number 6. If you hit shift number 6, your answer will probably look more like 4.8 meters, shift number 6. Sorry, meters, second, shift number 6, minus 1. So it'll look like that in the chat. Okay, can you have a go at B and C and then pop your answers in the chat? So it says he continues at the speed for 2 hours, right? We just found his speed is 4.8 meters per second. What distance did he travel? Okay, so we practiced this equation at the start there. So what distance does he travel if he continues that speed for another 2 hours? So have a go at it and pop in the chat. So he continues at this speed for another 2 hours. What distance did he travel? You're close. So 2 hours, remember, it has to be in seconds. So it has to be in seconds. Ah, Catalia, beautiful. Good job. Yes, beautiful. Good job. Okay, so what we know is speed equals distance divided by time. So get more people with Catalina. So distance is going to be speed times time. So the speed was 4.8 times by the time. Remember, the time is 2 hours. So 2 hours, I have to put it into seconds, right? It's the only way these units work. Everything has to be in seconds here. So to put it into seconds, what I have to do is I do 2 hours. I have to multiply by 60 to put it into minutes and multiply by 60 again. So it's 2 times 60 times 60 to put that into seconds. So we do 4.8 times 2 times 60 times 60. And you get a final answer of exactly what Catalina said, which is hopefully everyone got 34560 meters. Okay, so 34560 meters. 34560 meters. So yeah, so today, like we just said, today is more us just jogging your memory, and then tomorrow we're starting more of the year 12 content. But I just want to make sure we're okay with rearranging equations today, how we're supposed to do it for year 12 physics, and how to write our units, okay? Okay, C, what do you think? If he stops suddenly, so stops, it takes him 1.5 seconds to stop, what's his acceleration? Can you pop in the chat? Because 120 is 60, 120 is you doing 2 times 60, right? That's you putting into minutes. So Anina, sorry. So 2 hours, if in minutes would be 2 times 60, but remember it's meters per second. So because we had it in meters per second, I had to put it into seconds. So it's 2 times 60 to put it in minutes times 60 again to get it into seconds. Yeah, 3.2. Kelly, I'm saying your name wrong. I'm sorry because you're flying free. You're doing so good. Yeah, fab. Anyone else get the same as Kelly? Anyone else get the 3.2? Aishan, lovely. Nice, good job. So again, to find acceleration, we do final speed. He stops, so his final speed is 0 minus his initial speed. His initial speed, we calculated earlier, was 4.8 divided by the time. The time was 1.5. So in your calculators, you do 4.8 divided by 1.5. Hopefully everyone gets negative 3.2 meters per second squared. So negative 3.2 meters per second squared. Nice, nice, nice. And that's exactly how I want to put in the chat. Yes, I'm in Ishias or Fernandez. Beautiful. Yes, good. Okay, so I'm going to leave the challenges there if you want to have a go at them later. But I want to, and we can maybe come back to them at the end, but I want to just keep seeing how we're doing from GCSE. Okay, so year 12 baseline test. I gave this test to everyone coming into year 12 physics to see if they actually have woken up from summer. So this is stuff you should know how to do from your GCSEs, and you need to know how to do it to go into physics, okay? So can everyone just give a quick go at each question as we go through them? So the first one was 4.5 kilometers meters. Yep, fab. Oh, -2, careful. Yeah, good. So an easy way to do it, and the way that you should be remembering it now, is a K means it's times 10 to the power of 3. 1K is 1 times 10 to the power of 3. So the way you should, and the way you want to write it in physics is 4.5 times 10 to the power of 3 meters. Okay? So 4.5 times 10 to the power of 3, that's how we want to start writing in physics. So I know in GCSE, you probably just said multiply by 1,000 and multiply by 1,000. That is the same number. Those are the exact same things, but this is how we're going to start writing it in physics. Okay? So everything's always going to be written with your standard form. So 4.5 times the power of 3. This one, millimeters, can we try writing it the physics way? So instead of, oh yeah, beautiful, Ishan, lovely. So it's 7.2 times 10 to the power of what? So remember milli, so kilo is times 10 to 3 bigger. Milli is times 10 the negative 3 smaller. Yeah, beautiful, Amina. So we want to write 7.2 times 10 to the power of negative 3. And yes, like everyone wrote in the chat, that's the same thing as 0.0072 divided by 1,000. They are the same thing. But to be fast in physics now, instead of typing this in your calculator, just really quickly, I know milli is -3, so it's just 7.2 times 10 to the negative 3. Okay. Okay, what's the next one? What symbol is current? Hold on, don't fly ahead. Current, Xavier, beautiful, thank you. Oh no, current, Xavier, you fell in the trap. Amps is the unit, not the symbol. Oh, CFK, you did it too. Okay, so not what the unit is, what's the symbol we use for current? Yes, lovely. Sorry if I say it wrong. Suransu, beautiful. Yes, Fernandez, beautiful. So the symbol we use for current is a capital I. The unit, like everyone said, is amps, but the symbol in our equations is I. So you might remember the equation, and you should know it. Another one to learn here is Q equals IT. Charge equals current times time. So that's what the next question is. What's the units for charge? So what's the units for charge? Yes, Aisham, beautiful. Coulombs. Nice. So unit of charge is coulombs. And how I learned it, the queen equals it was how I learned this. So the queen equals it. She's the it girl. The it girl is cool. So that's why it's measured in coulombs. Okay, so charge is measured in coulombs. Yeah, fab. Coulombs, nice. Okay, so this again, just practice in standard form. How would you write that number in standard form? Chloe says it's going to be 6.5 times 10 to the power of 5. Do we agree? Do we disagree? So 6.5 times 10 to the power of 5. Catalina says, nope, it's going to be 6.5 times 10 to the power of negative 5. Good job. Yeah, so Area, sorry. When I was in school, the queen was still alive. So I learned this equation as the queen is the it girl. So queen equals it, Q equals IT. And because she's the it girl, she is cool. So that's why charge is measured in coulombs. And this is an equation you need to memorize. Yes, good job, right? So it's 6.5 times 10 to negative 5. Because how I do it, if you take your 0, there's 1 place smaller, 2 place smaller, 3 place smaller, 4 place smaller, 5 place smaller. So 6.5 times 10 to the negative 5. Nice. Okay, this comes up quite a lot in physics as well. It's always 1 mark at the end. It'll say give your number to 3 significant figures. They do it a little bit in GCSEs, but they do it a lot more if you do paper 3 in physics. So you have a paper in physics in AQA, it's just all practicals. So what is this to 3 significant figures? 41.3 is beautiful. Lovely, good job. Because clearly this 5 here means we round up 41.3. Nice. Okay, what about this? How would I make you the subject of that equation? How would you make you the subject of the equation? Square root v is, yeah, nice, nice. Ah, Aisham, beautiful. Yes, nice. So if we have v squared equals u squared plus 2as, first thing I'm going to do is subtract 2as from both sides. So I subtract 2as from both sides. I have v squared minus 2as equals u squared. And I just wanted u. So what that means is I have to square root both sides. That's why it's v squared minus 2as. Yes, so the square root, nice, of v squared minus 2as, all inside that bracket. Xavier, are you saying I got a strong accent? Okay, what about this one? How would we sketch the shape of this graph? So it's another thing you need to know in physics is what is, yeah, thank you, Priyan, that's beautiful. And I'm sorry to see your name, so thank you for giving it a go. Yeah, nice. So hopefully everyone knows the equation of a line is y equals mx plus c. Okay, so if you don't know this, again, something you need to know. So c is our y-intercept. So the y-intercept, so there's my x and there's my y. The y-intercept is positive 5. And then like Priyan said there a second ago, the gradient is what the m is. The gradient is negative 2. So that means it's going to be a line that's going downwards, and the gradient of that line is always going to be negative 2. Yes, nice, Justy Klein, beautiful. So because the gradient is negative 2, that means the vertical divided by the horizontal is negative 2. If my vertical is 5, 5 divided by something is going to be negative 2. So what we want to do is find out what that point is. So that point where it's going to cross the axes, we can write is going to be 2.5. So that's nice. Yeah, nice, good job. Okay, moving on. Next one then is just practicing our acceleration again. So can you have a read here? So it says where falls at a steady speed of 50 for 10 seconds. She opens a parachute. After another 5 seconds, she's fallen at a steady speed of 10. Can you tell me what the average acceleration is? Pop in the chat. So this is an 8-mark question. What's the average acceleration? So remember, there's an equation you have to remember now, and we practiced it a second ago. So hope we're all thinking acceleration is change in velocity over time. Again, you don't want to waste any time looking at a data sheet for that one. We just want to remember it. So what is the change in velocity that we're going to use, and what time are we using? Yep, nice. Good job you too. Yes, good job. -8, good job. -8 meters per second squared. Beautiful way to type it in. 3 of yous. Oh, good job. Yes, nice. Because hopefully everyone's saying, it says, calculate the scalar's average acceleration from when she opens her parachute. So when she opens her parachute, what we're going to use is her final speed minus initial speed over time. So what we have to do is, I've lost where I'm at. Yep, -8. Yes, nice, good job. Yeah, that was fine for you. Nice. So hopefully then what we're thinking is we're just going to do 10 minus 50 over 5. So it says 10 minus 50 divided by 5 gives me my -8. Nice, good job. Because her final speed was 10. She started at 50, and it said it took her 5 seconds to drop from the 50 to the 10. Nice. Why did she reach a steady speed? Good job, terminal velocity. And then it's a 3 marker, right? So we're going to say initially she has a really high acceleration. Then what increases as her speed increases? Yeah, she reaches terminal velocity. I loved astrophysics. I did. You learn about exoplanets. You learn about the sun. The sun is mad. So the sun is supposed to be like a fireplace, really hot at the center and get cooler the further you go out. But the sun is really hot in the center, and then it gets cooler, and then all of a sudden it gets hot again. And physics can't explain why yet. So that's probably going to be a big Nobel Prize if everyone figures it out. Yeah, Rishit, thank you. So air resistance increases. So AR for air increases as our speed increases. So we're going to get marked for that. Until what? Thank you, Aishan, beautiful. Until the resultant force, the difference becomes 0. So then we know they're traveling at a constant speed. Nice. Okay, next one. Why is that speed then lower when she opens a parachute? Yep, until both balance out area. Nice. So why is the speed lower when she opens her parachute? And the last question there is, can you also figure out the gravitational force on her? So why is the skydiver's equilibrium air resistance? Yeah. Parachute increases the surface area. That's nice. Priyan, beautiful. Kara's beautiful. Yeah, good job. Right, because when something was a parachute, there's so much surface air there for the air particles being in contact with. So we're going to say the air resistance increases because the surface area has increased. That's nice. Good job. Lovely. And then this equation we have to memorize as well. And then beautiful, wider surface area. Nice. Okay, this one, we know her mass. How do we figure out the gravitational force acting on her? Everyone pop in the chat. We know her mass. How to figure out the gravitational force? Oh, it depends what number you've used. I didn't get 725.2, but you've probably used a different number than me. 9.81. Yeah, Priyan. Beautiful. Yes, good job. So what I do is W equals mg. Weight is mass times gravity. Remember, weight is a downward force due to gravity. So that's how we can always get anything in kilograms into a Newton. Like they multiply by G. So G in year 12 and year 13, you have to learn is 9.81. So I know sometimes you learn 10 and then maybe you learn 9.8 when you're in GCSEs, but now we have to use 9.81. So all you do is 74 multiplied by 9.81. So 74 multiplied by 9.81, and I got 679.32 newtons. So just check that. So 74 multiplied by 9.81. And I can't do math because it's completely wrong. Where did I get? I don't know what I typed in the calculator there a second ago, sorry. 725.94 newtons. 725.94 newtons. I apologize. 725.94 newtons. Just declining, I'm sorry. So 725.94 units. Okay, so I know everyone thinks, like, what's the point in that one? What's the difference really? But you can clearly see that would round up to 726 now. So 725 would be wrong, right? So the 9.81 does matter. So just make sure that's another thing we're making a note of. W equals mg. We're always going to use G is 9.81 now, okay? So 9.81. 9.81. Okay? Okay, we have what, 6 minutes left? We're going to get 2 more done. 2 more sets of questions. Hopefully, we all remember waves. This is quite a nice question about waves. And yes, there's been a multiple choice on this in your A-level physics question. So just make sure we want to be pros those, right? There's no chance we want to miss this 1 mark. So first one is, what's the wavelength of the water wave? Can you pop in the chat? What's its wave amplitude? Pop in the chat. And what's its frequency? So just have a go at all of them. The formulas. So the ones we've done so far is speed is distance over time. Acceleration is change in velocity over time. And W equals mg. Nice. Thank you for 10 centimeters. Good job. So wavelength is 1 full wave. So it starts here. 1 full wave is peak to peak. Peak to peak, I come down. And I can clearly see that's my 4 centimeters. Nice. 4 centimeters. What is the amplitude? Just declining. I'm in. Beautiful. Sir Sue, beautiful. Yes, beautiful, good job. So the amplitude is the maximum displacement from the equilibrium. So I find the 0, that's where my equilibrium is. And I want to see what's the maximum displacement from the equilibrium. And again, it's 3 centimeters because it says centimeters for me. Yeah, nice. Nice, Elijah. Thank you. I haven't seen your name yet. Nice, Elijah. Okay, what about frequency? So this one you do need to know the definition for as well for year 12. So frequency, remember, is the number of waves that pass a point in 1 second. So the number of waves that pass a point in 1 second. So it says here, I've got 12 waves in 4 seconds. I want to figure out how many waves pass in 1 second. So how many waves pass in 1 second? Yep. Sorry if I say it wrong. Ahmad or Inji, yeah, beautiful. It's going to be 3 hertz. Nice, good job. I'm in, beautiful, 3 hertz. Yeah, good job. This side got divided by 4. So we divide this side by 4 to get 3 waves in 1 second. And nice that people remember it's hertz. And then just be careful there. So Ahmed, if you look at theirs, or Inji, sorry, 3 hertz. If you write HZ, you're not going to get any marks. It's not a small h. Okay, small h is something different in physics. You'll learn it as Planck's constant that you'll have to learn in year 13 a bit more. You have to use a capital H when you're talking about hertz. Okay, so 3 capital H, small z, 3 hertz. Nice, flying through. Okay, so I think this is going to be our last one. Am I right? Oh, got 2 more. Right, what's this one then? What is an alpha particle? So you do radiation as well at the end of year 12. So what's the structure of an alpha particle? Does anyone remember? What's the structure of an alpha particle? A helium nucleus, nice, and then a min. So if you combine area and area and a min, if you combine both of those answers, you need both of them now. That's beautiful. And nuclei, lovely. Everyone said nucleus is good. Okay, so remember an alpha particle, we can never say it's a helium atom because a helium atom, we know from chemistry, has those electrons orbiting it. But a helium nucleus doesn't have any electrons. So an alpha particle, we're always going to say is a helium nucleus. And then for year 12 physics, you have to be able to say what that is. So in your periodic table, helium is 4-2. So what that means, I've got 2 protons and 4 take away 2 gives me 2 neutrons. So an alpha particle is made of 2 protons and 2 neutrons. Yep, nice. On to the next one. Which one is the least ionizing then? Which one is the least ionizing? See here, beautiful, it has to be gamma, right? So gamma is the least ionizing, and then because the most ionizing is always alpha. So we always write them alpha. So if you think, the way I remember, like the alpha meal is like the strongest meal. So alpha is the most ionizing, then beta is like the second one, the second down. So it goes alpha, beta, gamma. So gamma is your least ionizing. Yep, good job. So ionized, you have to be careful. There's 2 ways to write it. So we can't always assume that we're losing electrons. So just to kind of, it's nearly perfect. So you're always assuming that electrons are being lost, but that's not always what ionization is. So I mean, again, same thing. We're assuming here ionization. Yeah, just a kind, good job. So ionization could be the gain or it could be the loss of electrons. So you just have to make sure in your exam you write both gain or loss, gain/lose of electrons, because it didn't tell you, I'm not asking you it became negative, became positive. You just have to remember, you know, that ionization could be the gain or loss of the electrons. Nice. Okay, what then is part B? Anyone know its name? What is part B? So I got radio waves, something, then B. Yeah, nice. Good job. Yeah, nice. Good job. Infrared. Good job. Because this one must be micro. This one is infrared. This one is visible. UV, X-rays, and gamma. Nice. And again, this is something you don't get taught again in year 12. It's just assumed that you've remembered it. Okay, so again, you want to know this one. And you'll not be singing the EM song in year 12 physics. Yeah, infrared. Nice. Okay, so this was the last slide today. So I'm just going to leave it up if you want to have a go at it quick and pop it in the chat just while I'm talking. We've got a minute left. So it'd be nice if you could pop your answers in the chat just so I see how you're doing. Because electricity is a massive topic that you'll be doing in year 12 physics. Okay? So the key thing today is to just make sure you always have to write your units, not as meters per second. So where did I put it a second ago? We don't write this anymore because you don't get any marks. It's ms to the -1. And the equations that you need to remember is, yeah, V equals IR was another one I want to hear. So that's another one we need to remember. V equals IR. Because again, if you look this up after, you will see there's a massive booklet, a data sheet that you'll get given, but you only want to use that when you come along a question in your physics paper that you can't do, and you're like, how on earth am I going to do this? And then that's wasting time. So then you have to go back to your data sheet and you look through it trying to find that equation, but it is like 5 pages long, double-sided. So you can't waste time for every question trying to look back for these equations. But the pro is, because you'll be doing year 12 physics, you have a lesson nearly every day, so that constantly just be going into your head. So nice, people I saw in the chat here were thinking that one's 0.5 amps. Nice. This one's going to be 0.5 amps. Nice. We know V equals IR. So all I have to do here is find what the current is. So the current going through the voltmeter through A3 is 0.3 times by 20. So I do 0.3 times by 20. I get 6 volts. And nice, because it's a parallel circuit, the voltage across the branches is always the same. So it must be 6 volts here. Okay. You guys did amazing today. Like really solid, and it's really nice a lot of you started to type the chat near towards the end. So Elijah, you weren't like talking much at the start or pre-end, but it's really nice that you kept going and now you're talking loads. Area, thank you for like being on it from the start. Same thing, Aishan, I've been on it from the start, which is really nice. Yeah, Zachariah, nice. I've not seen your name yet as well, so thank you. CFK, you've kind of like been persistently in and out of it as well. So again, it just really helps me to see you guys like answering the chat, and it's for you guys, right? So just so you know, there is a homework. CFK, I did give you a shout out there, man. There is a homework up, okay? So I know like you're thinking, what? Why is there homework? This is summer, right? But this is just an intro course so you can see what it'll be like for the year. So all through next year, like I said, there'll be a year 12 course. So I'll teach a lesson and then you'll have homework after. So there is a homework, but it's, if I remember correctly, it's 3 multiple choice questions just to see if you learned the stuff today. So it probably take you, 2 minutes to do it, right? So it's just so you can see how the course works. So after every lesson, there'll be a homework. It's like for this one, it's 3 multiple choice questions. And then if you couldn't do it, it gets marked straight away. If you couldn't do it, I've made a video where I go through all the answers for you to make sure I do it like a little bit slower so that you can pause the video or just skip the video to the questions you want to do. Okay, so hopefully you've enjoyed today, and hopefully I will see you all again on Thursday. Yes? And thank you for making this hour enjoyable. It's been good crack. Oh, Jessie Klein. Yes, please do it. Yeah, and hopefully I'll see you guys a lot more over the next couple of weeks, right? We've got 8 lessons together. And then hopefully I'll get to chat to you for the year. I think someone said they're going to bake a cake. Enjoy your cake. See here, yes, I am. But I'm trying to lose the accent a little bit. But a lot of my friends are Irish and I've been hanging out with them recently. And I don't know what it's like if you guys have any family who's not from England. But as soon as you call someone from home, and the accent starts to come back a little bit more. So I've been hanging out with quite a few Irish ones recently. And it's come back a little bit hot, isn't it? Aria, it was you that the cake. What type of cake to eat? Yes, have a lovely day. Oh, you're a baker. I wish I could bake. Monkey Pickle Pants. What a name. Actually, I can't speak Irish. I can say one rude phrase in Irish that I'm not going to say here. But no, my school didn't teach Irish. So yeah, I just English, just speak English. So yes, so Ireland's a little bit different. Some schools, you have to learn Irish. But I'm from the north of Ireland. So mine's is a bit different. We weren't really allowed to learn Irish. Yeah, Priyan, right? Yes. So you talk normally and then you're with your family for a little bit, or your friends, and then all of the twangs come back. Dogs 100% have birthdays, but I miss my German Shepherd birthday and I feel really bad for it. We're gonna give him another birthday party. But yeah, you guys are free to go. So hopefully I'll see you guys on Thursday. Thank you for today. A dog-friendly cake? What do you mean? Like you're not putting sugar in it? I'm in. Have a lovely day. Thank you. Bye, guys. A German Shepherd. Yes, they're the best dogs. And I bet she talks about it all the time. They're like little humans. Oh, I'm sorry to hear. So a healthy cake area. Oh no, you can't beat a German Shepherd. So much love. Okay, so I'm going to tap out. So hopefully I'll see you guys on Thursday again, yeah? Have a lovely couple days of your summer.